Hello students, today we're doing lesson 7.6, solving systems by the addition method. Okay, so yesterday we did addition method also, but it was solve simple systems. So these aren't as simple to do, but they aren't difficult either. We're gonna have some multiplication in here also. So I'm gonna do two examples with you, and then I'm gonna have you do one on your own. Okay, so example one, I have x plus y equals 8. And 3x plus 2y equals 22. Okay, so if you notice on this one, if I add any of this up, okay, you don't have to write this part. If I add these up, I will not get even close to getting rid of one of them. And even if I subtracted them, I can't get them to be where one gets rid of the other one, right? So we're going to make that happen, okay? And how we do that is, remember when we're doing algebra, whatever you do to one side, you have to do to the other side, and it still keeps the equation equal. So I can do whatever I want to both sides as long as I'm doing it on both sides and the equation stays equal. So what I want to do here is I want to get rid of the x's. I just chose that because it's the first one on there. So if I want to get rid of these x's, then in front of this x, I need a -3, right? That would get rid of those x's when I add. Okay, but to do that, to make that a -3 in front of there, I have to multiply everything in this equation by -3. I can't just put a -3 in front of the x and be done with it. I have to multiply everything by -3. So I'm going to do that and do distributive property here. And I'm going to write it off to the side here. So I get -3x plus -3y equals -24. And then I'm just going to write my bottom equation. It's just going to stay the same because I don't want it to change. I want those x's to erase each other. Okay, so now I can add these. And now do you see that these make 0x? So I'm not going to write that down. And then right here I get -1y equals -2. So now I'm going to divide by -1, and I get y equals 2. Okay, I solved for y. Now I'm going to go back and solve for x. And to do that, I'm going to take my first equation here, and I'm going to keep it the same way. I'm not going to use this one that I changed, okay? Don't ever use the ones that you changed. Use the original ones. So now I get x plus 2. Remember, here's my y equals 2. And then I'm going to subtract 2. So I get x equals 6. Okay, so here's my answer. I have 6 and 2. Okay, so this is still called solving by addition method because I'm still adding. I just had to do one more step and I had to multiply. Okay, next one, example 2. Remember, you're going to do one on your own in just a minute. Okay, now we have 2x plus 3y equals 6, and 3x minus 2y equals 8. So this one's a little bit more complicated. Okay, on this one, I want to get rid of my y's, and the reason I picked that one was because one of them is already plus and one is minus. So that's going to make it easier on me to solve it. Okay, but there's nothing I can multiply by to make these the same, right? I can't multiply 3 by something to get 2, and I can't multiply 2 by something to get 3. So here's the trick you're going to do. You're going to multiply them both equations by something in order to make them the same. So how I decide this, or how you're supposed to decide this, is you take the two numbers that you're trying to make the same, and you say, what is my least common multiple of these two numbers? So a long time ago, at the beginning of algebra, we talked about least common multiple. And that is when you do, okay, 3, 6, 9, 12, you do the multiples. And down here I have 2, 4, 6, 8, 10. And you say, which is the least one they have in common? So actually this one would also be 12. So the least one they have in common is 6. So they also have 12 in common, but that one's bigger. So I want to use the least common multiple. So now what this means, once you find the least common multiple, it's kind of like finding a common denominator if you know how to do that. But once you find that number, 6, then that's the number you want to make both of these. So I want to make this one a 6, and I want to make this one a 6. Okay, so how do I do that? Well, to make this first one, the top one, a 6, I would multiply everything in this equation by 2, right? So let's go ahead and do that, and then we'll talk about the next one. So that would make it 4x plus 6y equals 12. So see how I multiplied everything by 2, okay? Now, on this bottom one, I want to make this 6 also, okay? So what would I multiply that by? I'm going to multiply it by 3. So I'm going to multiply everything here by 3. So that's going to give me 9x, see, 3 times 3x, minus 6y equals 24. Okay, so I just multiply everything times 3. Okay, now look at what I have over here. What I have is 2 equations that I can actually add and something will be gone. So I get 13x. My y's are going to be gone because I have 6y minus 6y. That means it's 0y. And that's going to equal 36. Then I divide by 13. And I get x equals 36 over 13. That's it. Okay, it's a fraction. Okay, so that's a nice ugly number that does not make it easy to do our next part. And usually on these examples, they like to give you some of these so that you see that fractions can be done. So what I'm going to do is I'm going to take that first equation, remember not what you changed it to, just the first equation, and I'm going to substitute in this for x. So I'm going to have 2 times 36 over 13 plus 3y equals 6. Okay, so lots of work here to do. And if you have calculators and you know how to use your fraction key, that will probably help you a lot. Okay, so first I'm going to multiply 2 times 36 over 13, and that gives me 72 over 13 plus 3y equals 6. Then I'm going to minus 72/13 on both sides. Okay, so that's where it gets a little bit harder. So let me do some of my calculations. So to do this one, this is going to be 3y. I need to make the 6 into a common denominator of 13. So that's going to be 78 over 13. So that gives me 6 over 13. Is that right? Yeah, 6 over 13. Then I'm going to divide by 3. Well, it looks weird to put divided by 3 like this, and you can do that. You can do it with your calculator that way. I'm going to put divided by 3 like this because now I can do it without a calculator. So that means I have 6 over 13 times 1 over 3, and that gives me y equals 2/13. I know that looks difficult, and hopefully you won't have any this hard on your test. It might, maybe for extra credit, but not on a test like that. But learn to use your fraction keys on your calculator, okay? If you have something like a TI 30X, then just Google fractions on TI 30X, and then it will show you how to use it. Or what's better is do a YouTube video on it. I don't want to do a YouTube video on calculators because a lot of y'all have different calculators, and so I don't want to do that, and then you have the wrong calculator, and then I would have to do like 5 videos on them, on all the different calculators. Okay, so my answer was 36/13 and 2/13. Okay, now I want you to do one, and this one is not going to be a fraction one. I'll give you one that is not a fraction one. Okay, and let's see. Let's do, okay, so example 3. I want you to do 2x plus y equals 15, and x plus 2y equals 18. Okay, so go ahead and hit pause and solve that problem. Okay, now that you're back, I'm going to go ahead and solve it by changing the x's. You could have changed the y's, it will come out to the same answer. Okay, so I'm going to multiply everything in the second equation by -2. So my first equation is going to stay the same, just rewriting it. And my second equation is going to be this. Okay, so I multiplied everything by -2, and that's what I got. So now my x's are gone, right? They equal 0. I get -3y equals -18. And then I'm going to divide by -3. I get y equals 6. So now I need to find out x. So I'm going to substitute that into this first equation. It doesn't matter if you substitute it into the first equation or the second equation. You'll get the same answer. I'm going to -6. I get 2x equals, oops, I think did I do something wrong on that one? Hold on, this is not coming out to the right answer. So I want to see what I did wrong here. And this is always something that happens in your daily life with algebra, is trying to figure out what you did wrong. And I might have written down the problem wrong. So let's go ahead and finish this and see if what I get here. So I get divided by 2, x is 9/2. Okay, so if I put those back in there, yeah, that should be, no, that does not work. So what did I do wrong here? Can anybody see what I did wrong? This is often what happens in my classroom, is sometimes something will go wrong and I'm trying to get students to help me see what is wrong with the problem. And now I just found it. This is not 18 right here. This is 21. So my answer to y should have been 7. Okay, so you see how I did that? I got it wrong and I came back up here to try to figure out why it was wrong. Okay, so now I'm going to put 7 in place there. -7, 2x equals 3, 8. And then I'm going to divide by 2. I get x equals 4. Okay, so your answer should have been 4, 7. Okay, and if you did it the opposite way, if you got rid of the y's instead of the x's, you still should come up with the same answer of 4, 7. Okay, that's it for today.